Hey everyone. Our lesson today is short and sweet, so I'm sure you'll be happy to hear that. I definitely will keep it under 20 minutes this time. So we have um, this similarity theorem here that says if two triangles are similar, right, they're telling us that two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So we first need to determine what type of part these segments are. So we have, let me draw in segment BD and segment FH, right? They are perpendicular to the segment AC and segment EG, but they're not bisecting AC or AG, so they're not perpendicular bisectors. They connect to the opposite vertex. So this is just a review, right, of the last unit. Okay, and so these are altitudes. And altitudes are just a fancy word for the height of the triangle. So what we're doing right now is we are going to make a proportion of our altitudes and set it proportional to a side. And we can choose any side. I'm going to choose the one on the left, so AB and EF are corresponding. So I'll do big triangle over small triangle would be my altitude BD over my other altitude FH equals my side AB over EF. And I could have chosen any side, that's just such a side that I chose. Okay, and we can do that because they tell us that the triangles are similar, right? So we have triangle PQR, triangle TUV, they're similar. It looks like we are bisecting angle Q and angle U, right? So if we're bisecting the angle, these are angle bisectors. Same idea here. We will set the angle bisectors proportional to a side. So if we do big triangle over small triangle again, okay, my angle bisectors are QS over UW, and I'll choose a side and its corresponding side. So this time let's do QR and UV. So QR over UV. Okay, and finally, we're still connecting to a vertex, right? But my angles aren't being bisected. My opposite segment is being bisected, not perpendicularly, right? It's just connecting to the midpoint of GH and KM. So if it is a segment that connects to the midpoint, it's a median. Okay, so the medians are proportional. So we'll say big over small, right? That's a preference, it doesn't matter. I'll say JH over my other median NL is proportional to, right? And we'll just pick two sides. So I'll say GH over KL. Okay, and we can use that to solve problems, which we'll do in 1 through 4. Okay, so I'm going to do 1 and 3, and you guys can do 2 and 4. So number 1 looks like a median. All right, and they tell us here at the beginning that the triangles are similar. So we're going to set the medians up so that we can find our median SW. Okay, so our medians are proportional. I'll put x over 15. And then we choose a corresponding side. So in this case, right, they give us 16 and 19.2. I think 16 sounds like the nicer number. That's ST, the first two letters in my triangle statement. So that is proportional to DE, right? Always check your statement. The first two letters, first two letters. So I'll say x over 15 equals 16 over 20. All right, that worked out nicely. And to solve for x, guys, you should be getting used to this now. We cross multiply, right? That's 20x equals 16 times 15, which is 240. And then when we divide by 20, we get x equals 12. All right, so we found our median SW is 12. All right, let's do it again. So here on number 3, they give us the angle bisectors and ask us to find side EF. All right, so EF is the first and the third of the smaller triangle. So EF is proportional to AC, right, which is 38. So let's set the angle bisectors in a proportion. We can say 32 over 24 equals 38 over x. Okay, and cross multiply again. That's 32 times x is 32x. And 38 times 24 912. And we divide both sides by 32 to get x equals 28.5. Which that sounds like a reasonable answer. So my side EF is 28.5. All right, so you guys can do number 2 and 4 as practice. And we're going to move on to a proof. All right, so this is a proof having to do with similar triangles. It's actually a triangle within a triangle, right? So we have triangle ORS is inside of HRE. And we're trying to prove, knowing that the triangles are similar, that parts are proportional. So OH over OR, OH over OR is proportional to SE over RS, right? And I agree with that. That looks pretty reasonable. So we'll start with number 1. Number 1 is OS is parallel to HE. That's given. Our favorite, right? Given. And anytime you have parallel lines, you should think of angle relationships. So we have parallel lines cut by a transversal. Don't worry, I'll erase this. Cut by a transversal, right? And it says angle ROS, so that's this one here, is congruent to angle H. Well, I agree, because those two angles are corresponding. All right, and then they say, okay, well, you have parallel lines cut by a different transversal. Now we have angle RSO is congruent to angle E. Well, sure, I agree with that too, because those two angles are also corresponding. So this number 2 must be the corresponding angles theorem, but I'm just going to say corresponding. Okay, so I was actually wrong. They didn't tell us that the triangles were similar, but the triangles are similar. And how do I know that? I know it because of the angle similarity criterion, right? So on our last homework, it was just angle similarity, right? That's an A, not a triangle. Angle similarity is how we prove triangles to be similar. So if these triangles are similar, let's state it. we'll say triangle, and we can name the triangles however you want, but I'll say triangle ORS is similar to triangle, I went from O to R, then to S, right? So the statement matters. ORS is similar to HRE by angle similarity. Okay, number 4, let's see what this is about. So HR is the whole segment on the left, right? HR is the longer segment, the longer triangle, over OR is equal to RE over RS. Yes, I agree, sure. Okay, so what could the reason be? So I actually went on Algebra Nation, looked up this one because I wasn't sure. If we're saying that the parts are congruent, right? So the side of the larger triangle is congruent to the side of the, sorry, I didn't mean to say congruent. The side of the larger triangle is similar to the side of the smaller triangle, right? So this is the similarity rule of proportional sides, which makes sense. They're just saying that given a proportion, we can say that the sides are similar. So that's the similar rule of proportional sides, which just sounds like a bunch of nonsense, but you never know what to expect on your EOC. Okay. So number 5 says the segment addition postulate. All right, so remember we're moving from 4 to 5. Okay, and in the denominator of 4 and 5, we have OR, then RS. So instead of HR is the whole segment of the bigger triangle. Let's go ahead and break it up to be HO plus OR instead of HR. So I'll put HO plus OR over OR. And then we do the same thing with the other side. So instead of RE, I'll say ES plus SR over RS. Okay, so the two smaller put together equals the longer. All right, and that is the segment addition postulate. So I think we satisfied that pretty well. Now, moving from 5 to 6 now. We're going from 5 to 6. What do? It looks like they break this up so that HO over OR plus OR over OR. So they're really just kind of simplifying the fraction, right? So this is fraction addition. Okay, and we do this all the time when we're simplifying. But simplifying fractions, let's just say that it's fraction addition. Okay, and then from 6 to 7, well, OR over OR, anything divided by itself is 1. RS divided by RS is 1. Okay, so they really just simplified. Okay, and then the rest is pretty easy. Hopefully you can see number 8. They say subtraction property of equality. So that's your hint that they're subtracting. And they're going to subtract the thing that they have in common on both sides. They're going to subtract 1. And if we subtract 1, we're left with HO over OR equals SE over RS, which is what we were trying to prove, right? And we're done. Hooray! Okay, one more problem. Prove triangle ACB and triangle PQR are similar by applying properties of transformations. All right. So we're looking at the two triangles, and they do look similar. They look like they're growing, right? And that means if they're growing or changing, it's non-rigid. Okay, and the only transformation that we know that's non-rigid is our dilation. So it's definitely a dilation. Excuse me. So let's just go ahead and check the coordinates. We'll do PQR. Triangle PQR is similar to triangle ACB. And let's just check. So P, Q, and R. The coordinates of P, -1, 4. Q is 1, 2. And R, 4, 2. So point A, point C, and point B, A is at -2, 8. C is 2, 4. And B is at 8, 4. Okay, so it looks like it was, oh my, sorry. It's dilated. It's definitely dilated. Triangle PQR by a scale factor of 2, right? You can tell from looking at the coordinates. We multiply by 2, so the scale factor is 2. All right, and we're done. I kept it under 20 minutes. Please do 2 and 4, and I'll see you tomorrow.